Hey everybody, it's Dynamic Math here. I just wanted to share with you really quickly an activity that I love to give students in geometry or trigonometry, wherever, that actually has them consider just one question. How fast are you spinning? Now, we think, well, Earth is turning on its axis, right? Yes, if we assume Earth to be a sphere, right, then and we spin once in 24 hours, we could say that we have an angular speed of 360 degrees divided by 24 hours, which is 15 degrees per hour, right? But 15 degrees per hour is an angular speed, does not translate to the to the same linear speed for everybody, because people over here on planet Earth, right? If you live at the equator, you spin this distance, right, the circumference of the Earth in 24 hours, versus if you were to live, say, somewhere up here, right? If you think about it, we can enter our latitude, right, no matter where we are. So people in the southern hemisphere, I use the negative values for it, sorry, and northern hemisphere use positive values. So where I am currently is roughly 41 degrees north latitude, so I'll put that right there. And so I'm kind of, just to get a little bit of insight to see what I'm doing here, right? I love creating this applet because this applet helps students conceptually see that their latitude is really the measure of a central angle here, whose vertex is at the core of the Earth, right? So that's a 41-degree central angle right there. And I can actually change that latitude, and we can see, well, here's Santa Claus and his elves, right? And all the way down here with the penguins at the South Pole. So we could clearly see that, that in a 24-hour period, right? If your circle of latitude is orange, right, and you are at the blue dot, the blue point, so you move that distance in 24 hours. So the key question is, how do we find it? Well, the reality is, if we find the circumference of the Earth, right, then the circumference of this orange circle will be less than or equal to the circumference of the Earth at the radius there. But how much less? And what's the scale factor? And it actually turns out that students discover that it really is a function of the cosine of this latitude angle right here. So I like to engage students in a performance task to kind of figure that out for themselves and come up with the results, and it's pretty cool. So thanks for watching.